Hi everyone. Let's go ahead and finish up our lesson 5. It may take 2 videos, but I'm going to try for one. So we were working on lesson 5, module 3, student page C. We had set up our fractions. The double hex was the whole, blue was 1/6, green was 1/12 from the last page. We'd already decided what our common denominator was. We said 12 because we always start with the larger number and check it first, and it worked. So then to make 1, and we talked about 1's a whole number, so you put it over 1. To make it into 12, you have to multiply numerator and denominator by 12. To make 6 into 12, you have to multiply numerator and denominator by 2. This one is ready to go. So our new fractions are 12 over 12, and that makes sense, right? Isn't that 1? Anything over itself is 1, and that's what the double hex is. It's our unit. And then we have 2 over 12, and then 1 over 12. So 12 over 12 minus 2 over 12 minus 1 over 12 would be what? 9/12? 12 minus 2 is 10, minus 1 is 9. So can that be simplified? 2 doesn't go into both of them. The next number we try is 3, and 3 works. Yay! So our final answer when we simplify both of those by dividing by 3 is 3/4. And now we know it's simplified because nothing goes into both 3 and 4 except 1. So the next one, I copied this down after the video was over so I wouldn't have to keep turning over the page. Double hex is 1, red is 1/4, blue is 1/6, green is 1/12. So I filled that all in. And again, you want to make that whole number 1 over 1. So start with the largest number. 12. Does 6 go into 12? Yes, yes, yes. So there it is again. We're going to have all 12s again. So go down the line and do the same thing we did on E. To make this one 12, we have to multiply by 12 over 12. To make 4 12, we have to multiply by 3 over 3. To make 6 12, we're going to have to multiply both numerator and denominator by 2. And this one's already good. So that leaves us 12 twelfths, which makes sense. That's 1, minus 3 twelfths, minus 2 twelfths, minus 1. So 9 minus 2 is 7, minus 1 is 6 twelfths. So we have 3, 4, 5, 6. 12 minus 6 is 6. That looks good. So think about the procedure we're doing because we're going to write it down here on number 4. So first we find a common denominator. Then we switch all the fractions to the new denominator, making equivalent fractions. Remember, 1/6 is still equivalent to 2/12. Then instead of adding, like in addition, we subtract the numerators, but we still keep the denominator the same. And then our last step, as always, is to simplify. And I can see 6 goes into both of these. And you could have done 2 and then 3 on the next step. But I saw right away 6 works, so that leaves it with just one step. 6 divided by 6 is 1. 12 divided by 6 is 2. So there's our simplified fraction, 1/2. And we already did this. That's just what we did up here. So we're done with 3. So let's go down to 4. So how would you describe the algorithm for subtracting? So we need to talk about the exact same thing we did when we were doing addition, just what I said in words up above. So first we find a common denominator. And rewrite each fraction as an equivalent fraction with the common denominator. Then once we get the common denominator for all the fractions, then think about what we did. Then we subtracted the numerators, kept the denominators the same. So that's what we need to write next. Then we subtract the numerators. And keep the denominators the same. And what's our last step with every fraction problem? Simplify. So last, simplify. So first we find a common denominator and rewrite each fraction as an equivalent fraction with that common denominator. Then we subtract the numerators and keep the denominator the same. Last, we simplify. So if you didn't get all that down, just stop the video now and copy it. I'm going to go ahead and go on to the last page. So now we're just working on skill development. Let me shut the window. Barking dog next door. Okay, so this is just practicing the skills we learned. Then we're going to add in some mixed numbers and show that they're done pretty much the same way as these are. So we're going to have addition and subtraction mixed. So we need to follow those rules we just wrote down. So first we find a common denominator. Start with the largest, 6. Does it work? Yes. Then we rewrite equivalent fractions. So we make them equivalent by doing whatever we do to the denominator, we do to the numerator. So 3 times 2 is 6. So multiply numerator and denominator by 2. So that turns into 2, 6 plus 5, 6 already has a common denominator. So 7, 6. And if the directions just say what these say, you're done. If the directions say write as a mixed number, then we would have to do one more step, remember. So we would take 6 goes into 7. Remember, the number in the denominator always goes outside once. 1 times 6 is 6. Subtract, and we get 1/6. So if they asked you for a mixed number, you would write 1 and 1/6. If they had these directions on the test, just leave it 7, 6. Why do an extra step if you don't need to, right? So this would be called a simplified fraction. This would be called a mixed number. Okay, next we have 7 and 4 as our denominators. So I start with 7. So does 4 go into 7? No. 7 times 2 is 14. Does 4 go into 14? No. 7 times 3 is 21. Does 4 go into 21? No. 7 times 4 is 28. Ding, ding, ding. There's our common denominator. So that trick works every time. Just start with the largest one and just keep adding 7, or 7 times 1, 7 times 2, 7 times 3, until you find one they both go into. So 28 is our common denominator. And 7 needs to be multiplied by 4. So that means 5 does too. 4 needs to be multiplied by 7. So that means 3 does too. So then we get 20 28ths minus 21 28ths. And the rules for adding and subtracting sign numbers are just the same. So if you have $20 and you go out and spend 21, what's your bank account going to be? -1, right? So -1 over 28. So now we're just adding in the other modules to module 3 and showing you, yes, subtraction is exactly like subtracting integers like you did on your first test. So 20 minus 21, when the signs are different, one's positive, one's negative, you subtract and keep the sign of the larger. So -1 28th. Now, if it was 21 28ths minus 20 28ths, then it'd be +1. But the larger number in this case is negative, so that's why the answer has to be negative. And if you think of money, it makes sense. If you have 20 and you spend 21 on your debit card, you're at -1. And then it also works when you do 3 fractions. As we saw on the other page, it doesn't matter how many fractions, you follow the same process. So the largest number is 10, so let's start doing multiples of 10. So 10, 5 goes into 10, yep, 4 doesn't though. 10 times 2 is 20. Yes, yes, yes. Bingo! There's my common denominator. So now we need to decide what to multiply by. 5 times 4 is 20, so multiply numerator and denominator by 4. 4 times 5 is 20, so multiply numerator and denominator by 5. And 10 times 2, so that one is multiplied by 2 over 2. So we get 4 20ths plus 5 20ths plus 6 20ths. 9 and 6 is 15 20ths. Or you could say 10 plus 5 is 15 20ths. Does that look simplified to you? Nope, it ends in 5 and 0. What number goes into everything that ends in 5 and 0? 5. So 15 divided by 5 is 3. 20 divided by 5 is 4. You can always check it, times 5, and you should get that number back. So these aren't too bad, are they? Okay, so let's do one more of the type we just did on the other pages, and then we'll switch to the mixed numbers, and I'll show you how those are not really too much different. So our last video will probably be these 3. I added one in. I'll show it to you on the next video. So we have a subtraction problem. So this time the numbers are getting a little bigger, but that's okay. We don't care. We use the same process. So 20, whoops, not quite in the picture. 5 goes into 20, but 12 doesn't. 20 times 2 is 40. 5 goes into 40, but 12 doesn't, because 12 times 3 is 36. 20, 40, 60. 20 times 3 is 60. 5 goes into that. Yes, 12 times 5 goes into that, and 20 does. So there is our common denominator, 60. So 20 times 1, 20 times 2, 20 times 3, and we found a number they all go into. So our common denominators are going to be 60. I put in my subtraction signs. Now we just have to find the new numerators. So 12 times 5 is 60. So multiply numerator and denominator by 12. 12 times 5 is 60. So multiply numerator and denominator by 5. 20 times 3 is 60. So multiply numerator and denominator by 3. So what are we going to have? 12 times 3 is 36 60ths minus 5 60ths minus 21 60ths.